Hi, welcome to my channel. In this video, we want to solve the following problem. ABC is a triangle with angle A equals 90 degrees. From A, draw a line perpendicular to BC and cutting BC at D. Again from A, draw a line cutting BC at E and such that angle EAD equals 2 theta and angle CAE equals theta. From this, we deduce that 3 theta is less than 90 degrees. Given that BD equals 2 square root 5 over 7 units, DE equals square root 5 units, and AD equals H units, our goal is to find the value of H. And now for the solution. First, consider triangle ADE. Since the triangle is right angled, we have tangent 2 theta equals square root 5 over h. Using the identity, tangent 2 theta equals 2 tangent theta over 1 minus tangent theta square, we equate the two expressions for tangent 2 theta and cross multiply to obtain square root 5 minus square root 5 tangent theta square equals 2h tangent theta, or square root 5 tangent theta square plus 2h tangent theta minus square root 5 equals 0. An application of the quadratic formula with a equals square root 5, b equals 2h, and c equals minus square root 5 gives us two possible expressions for tangent theta. Minus h plus minus square root h squared plus 5 over square root 5. Since 3 theta is less than 90 degrees, theta is less than 90 degrees, so tangent theta is greater than 0. Therefore, we have tangent theta equals minus h plus square root h squared plus 5 over square root 5. Next, consider angle ABD, which is this angle. It equals 180 degrees minus 90 degrees minus angle DAB, which equals 90 degrees minus angle DAB. Since angle CAB equals 90 degrees, we have angle ABD equals angle CAB minus angle DAB, and thus equals 3 theta. Since triangle ABD is right angled, we have tangent of angle ABD equals h divided by 2 square root 5 over 7, and so tangent 3 theta equals 7h over 2 square root 5. Following this, recall the identity tangent 3 theta equals tangent theta plus tangent 2 theta over 1 minus tangent theta tangent 2 theta. Substituting the expressions for tangent theta and tangent 2 theta into the expression for tangent 3 theta, and then simplifying, we obtain 1 over square root 5 times 5 minus h squared plus h times square root h squared plus 5 over 2h minus square root h squared plus 5. Equating the two expressions for tangent 3 theta, we observe that square root 5 cancels out. After cross multiplying and combining like terms, we obtain 16h squared minus 10 equals 9h times square root h squared plus 5. Next, we square both sides to obtain 256h to the power 4 minus 320h squared plus 100 equals 81h to the power 4 plus 405h squared, or 7h to the power 4 minus 29h squared plus 4 equals 0. An application of the quadratic formula with a equals 7, b equals minus 29, and c equals 4 gives us two possible solutions. H squared equals 4 or h squared equals 1 over 7. Taking the square root, we obtain h equals 2 or h equals 1 over square root 7. To determine the possible values of h, we substitute h equals 1 over square root 7 into the expression for tangent theta, giving us tangent theta equals square root 5 over 7. Thus theta is approximately 40.2 degrees, and so 3θ equals 120.6 degrees. Since 3θ is less than 90 degrees, we reject h equals 1 over square root 7. Substituting h equals 2, we obtain tangent θ equals 1 over square root 5. Thus θ is approximately 24.1 degrees, and so 3θ equals 72.3 degrees. Therefore, h equals 2 is the solution to our problem. As an exercise, try to solve this problem and see if you can get the correct answer. This marks the end of the video. If you enjoyed this video, please leave a like and subscribe to my channel for more content. Thanks for watching and see you all next time.